Okay, guys, we're going to do the check your understanding on page 522, which is a complete confidence interval for a mu, or a true population mean. Okay, biologists studying the healing of skin wounds measured the rate at which new cells closed a cut made in the skin of an anesthetized newt. Here are the data from a random sample of 18 newts, measured in micrometers per hour. Okay, so we've got a list of 18 pieces of data. Calculate and interpret a 95% confidence interval for the mean healing rate mu. Okay, so we're going to do a complete confidence interval, state, plan, do, and conclude. Okay, so obviously our state is we want to estimate mu, the true population mean healing rate in micrometers per hour of a newt at a 95% confidence level. So that's my state. Move this up so you can read it. Okay, so that's all I'm going to be looking for. Simply state what you're looking for. And again, you can put that in the form of a question if you want. Okay. All right, for our plan, we have to state our inference method. So the last one we did was a one proportion z interval. Well, this one's going to be a one sample t interval. Okay, we use t intervals for means. Z's go with proportions, t's go with means. Okay. Of course, we have to go through our conditions. Okay, random. I do believe it's stated that the sample was random. Yep, stated a random sample was taken. Independence, let's do our 10%. I'm pretty confident that there's more than, what was my sample size? My sample size was 18 newts. I'm pretty sure there was more than 180 newts. And of course, newts, those little lizards, are independent of each other. Okay. Our normal, okay. All right, here we go, normal. It didn't say the population was normal. It didn't say anything about the population, the healing rate of a population of newts is typically normal. Our sample size is too small for central limit theorem, so I can't use that. So the only other option I have is to take my data, take my 18 pieces of data, and graph it. If it's roughly symmetrical with no huge skew and no major outliers, then I can assume normality, okay? I think the easiest, fastest graph to do in the calculator is a box plot, okay? So I'm going to take a second. I enter in my information, so I have my 18 pieces of data, and then I graph, do a box plot, do the one that shows outliers, so in case there are any outliers, you can look, or you can note them. Okay, hey, looks pretty good, roughly symmetrical, no huge skew, definitely no outliers. So that's going to be my justification for normality. So I'm going to say box plot is roughly symmetrical with no skew and no outliers. If there was some major outliers, or if there are outliers and like major skew, you really shouldn't do a one sample t interval. It's just not going to be a very valid interval, okay? But we're good. Now, you want to prove that you did a box plot, so I'm going to kind of reproduce this very quickly on my paper, and I'm going to label the key points. So let's see, something like that. Okay, so let's label our key values here. So we'll do our one variable stat. Let's see, I need to put it over here. I got a min of 11, Q1 of 22, median of 26.5, Q3, and my max of 40, and these are all micrometers per hour. Okay, so you're going to show some evidence that you actually did a graph. Okay, rough little sketch there. Okay, so all of our conditions are met. We're good to go. All right, let's do the do. So we have our point estimate, which is going to be our x bar. plus or minus our critical t here times the standard deviation of the sample divided by the square root of the sample size, okay? We're going to have to figure that out. We know what that is. That's 18. So we need to know our sample mean and our sample standard deviation. Hey, that's okay. We just ran one variable stat, so now we got it, okay? So I know my mean. I'm going to put it over here. I know my mean is 25.67. Standard deviation is 8.32, okay? So now I got to just figure out my critical t, okay? I'll do that work over here. So critical t, what is this, 95%? So these are both 5%, so this is 2.5%. So my critical t, is based off of 97.5%. We will do that in the calculator. Okay, so second var's inverse t. I'm going to do an area of 0.975. And my degree of freedom is going to be my sample size minus 1. So in this case, it's 17 because my sample size was 18, right? Okay. So I get a critical t of 2.110. Let's take it to definitely 3 decimal places, okay? If we want to check that against the table, might as well. 95% confidence interval, degree of freedom of 17. So 95% confidence interval, a degree of freedom of 17. Oh, look, I get the exact same thing. 2.110. Hey, very good. Okay, so now let's put it all together. So my X bar, I'm going to go ahead and fill everything in here. 25.67 plus or minus my critical t over times my standard deviation over the square root of my sample size. Okay? So there's my point estimate, there's my margin of error. So if I say 25.67 plus or minus, put that whole thing in the calculator. Oops, didn't mean to put that whole thing in the square root. Square root's got to go on the bottom. Sorry about that. Square root of 18. There we go. I'm going to get a margin of error of about 4.14. So I take my 25.67, I subtract 4.14, 25.67, and add 4.14. And then add, and there is my interval. So I'm going to write my interval down, 21.53 to 29.81. Okay, you want to show your setup with all your values, your point estimate, your margin of error, and then your interval. Okay, now I'm good to conclude. So I am 95% confident that the interval 21.53 micrometers per hour to 29.81 micrometers per hour captures the true population mean healing rate of a newt. Okay, and that one is finished. But real quick, that's our interpretation of our confidence interval. But remember, the interpretation of this confidence level means if I took many, many samples of this same size, okay, from the population of newts, about 95% of my samples would yield an interval that would capture the true healing rate of a newt. Okay, so about 5% of my samples, my interval would be a little off, a little high, a little low. Okay, so that's not too bad. 95% confidence level isn't too bad. Okay, that's it for now. See you next time.